All right, this is the Algebra 2 unit review. It's the Algebra 2 review for the Unit 6 test. All right, so it says here, state the domain, the range, and transformations of the following. Put into y equals and make a table to help you. Okay, so there's what they mean by this is that you can put it in your calculator, and we're going to do that. I have my calculator. All right. All right, so I have my calculator. It's an old TI-83. The functions are going to be different than your TI-84, but it's basically the same. All right, so the first thing we need to kind of know is what does this thing look like? All right, so we're going to put it in the y equals like it says here. It says put in the y equals and make a table. Well, I'm going to put it in a y equals. So I'm going to say y equals. So I'm going to hit the y equal button, get this, and I'm going to put this equation in here. Since it's already y equals, we're just putting this. So the square root is, mine is, you have to kind of make sure mine is in yellow. So I hit the second in yellow. All right, now I'm going to put this whole thing in here. And you have to do this correctly because if you don't, it'll mess up. So I'm going to say X, the X button's right here, minus 3. And now because I want to include the 3, since the 3 is under the radical, and you notice mine looks like a little short guy, I'm going to close the parentheses. You see how it has 2 parentheses? Now I'm putting all this in there. Now, I can hit graph and I can hit table. All right, so I'm going to hit graph because I think it's easier to see it. So there's my graph right there. All right, so you can see where it is. All right, and this is really helpful. All right, so notice that whenever you see, let's talk about the domain. The domain is my X values. All right, so this is my X values right here. All right, so domain means X. So this is my X values right here. So they want to know where does it start and where does it go. If you notice on the X, it starts around 3. All right, so that's where it first starts. And then it goes on, and this apparently goes on forever. So in your class, you probably talked about the little symbols. Remember, the symbols look like this. This means that you include the number. The parentheses means you don't include the number. All right, so there's a bracket that means included, and a parentheses means don't include it. All right, so if you look at our graph, we are on number 3, so we're including this number. So I'm going to say bracket, and I'm put the number 3 because that's where we start right here. You see it starts at 3. Now it goes on forever. So if it keeps going, it doesn't stop there. I can scroll here, and you can see, like if I hit trace, look, I'm going to follow this. I can find my trace. All right, I'm at 3. So there I see it. I'm following the line. You see the little bug. And then as I move over, watch it continues. See how it keeps going? So it's going on. It never stops. Because of this, we're going to say positive infinity. And we're going to put the little open thing there because it doesn't include. It just keeps going, going, going. The range is my y value. So we want to know how high this thing goes and how low does this thing go. Well, the lowest it goes on the y-axis is 0 because it's right here. That's 0. So the range is starting at 0, and it's exactly at 0. So we're going to put a little bracket, and we're going to put a 0. Now, it looks like it's stopping right here, all right? It looks like it's stopping here. And we can scroll over, scroll over, scroll over, scroll over, scroll over, okay? And you can see it keeps going a little higher and a little higher and a little higher and a little higher. All right? So we're going to just say that it is positive infinity. Close right there. Now, I know they want you to look at the table. So if you look at the table, you can look at these. All right. So if you look at it, look, it starts at 3. And the reason why it starts at 3 is because 3 minus 3 is 0. And so that's where it starts. You can't put 2 in here because that makes it a negative. And you remember a negative is like you can't have a negative inside of square root. And all these numbers here make it negative. So none of these work. So you look, I can go up here and it'll be all errors. All right. So we have to start at 0 because 0 minus 3 is, negative 3. We have to start at 3 because 3 minus 3 is 0. So that's a big clue for every one of these where it starts at. And you can see, look, the number keeps going up, 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 up. It just keeps going up. All right. So there we go. Now, how does this transform? Well, they want you to compare it to the transformation of a regular one. Let me get my window back. I'm just going to start. I'll just put it back in. All right. So I'm going to put the parent function in, and then I'm going to put this one in. All right. So the parent function, this is how you can do it if you can't remember. Whenever you see a number inside the parentheses, it goes left and right. So just to let you know, because it's inside the radical, it goes left if it's a negative, and it goes to the right if it's positive. It's the opposite of what you think. If it's outside the parentheses, if it's positive, you go up. If it's negative, you go down. Now, like I said, if you can't remember, this is the way you can do it on your calculator. You'll get to use a calculator. All right, I'm trying to fix it here. All right, so I'm going to put the parent function. The parent function is the square root of x. So I'm just going to put square root of x. And I got to put the closed parentheses. All right, that is the parent function. See, that's the parent function, but we added something to it. This time we put something inside the radical with it. So watch this. I'm going to scroll down, and I'm going to put this in there. Now remember, we got to put close parentheses in here. So I close it, so it includes it. Now the first one it'll draw is the parent. The second one, we want to see what's different about it. Like, how does it shift? Now, according to this, since this looks like a -3, see -3, it should shift to the right. So I'm going to hit graph. All right, so there's the original. Notice it starts at 0, 0, the origin. Now look where the next one starts, 3. So it moved over 3. So this is the original. So if you look, 1, 2, 3, it shifted to the right 3. So it transforms 3 units to the right. That's how you can tell. So you can do that, all of these like that. All right, so let's do this one. So we're going to go back. We're going to put this in the calculator. So I'm going to hit clear and clear. And so I'm going to put in a calculator. Anytime you see an equation, put it in the calculator as y equals or whatever. So that way it'll help you. So we got y equals here. I'm going to put the square root of x. Now notice I don't have +3 under there. So I'm going to close it. And now I'm going to hit +3. See the difference in the two? Okay, this is for x. Now I'm going to hit graph. I like looking at it this way because I can see it. Now you can see how it shifted. It actually shifted up 3. All right. So it shifts up 3 units. And again, you can put the parent function in there if you're not. So shifts 3 units up. Now, where does the domain start at? Remember, domain is my x value. So I'm put a little x here. All right, so x, where does it start on the x-axis? Remember, this is the x-axis. So where does it start at? Well, if you look, here's the x-axis. It looks like it starts right here, and it starts on 0. So we're going to say it includes 0. All right, and you know it's going to go on forever. So we're going to say positive infinity. And we're going to put a little not include. All right, range. All right, range is where does it start on the y-axis? Well, if it starts, look how low it goes. The lowest it goes is here, and that's at 3. So where y is 3. So we're going to include 3, and then remember, this is going up, 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 up. See how my pen's going up? It's still going up here, so it goes on forever. So we're going to say positive infinity, and we're going to put a exclude because we don't know how, it's not going to stop. It's going to keep going. All right, so the next one, do the exact same thing. So in fact, what I'll do is I'll put the original so you can see the difference. So here we go. And it doesn't hurt to do this. I mean, you can see, because like, look, if I graph it, there's the original. It starts at the origin and it goes that way. That's what they call the parent function. I used to call it in my class the grandfather of all lines, because it's like the starting, and you can add things to it, you can multiply things to it, you can divide things to it, and it's going to make the line do different things. All right, so I'm going to go back and I'm going to go down here. Now I'm going to put this in here, but notice it's a negative. Be careful. The negative is right down here below the 3. It always is. So you hit that first. See how I put a little negative in there? If you put the subtract sign, it will be wrong. All right, so then I'm going to put the square root. I'm just making sure I do this right. I want to hit the square root. I can put, oh, it's all in one thing, so it'll work. All right, so hit the second square root. And remember, we're going to put x plus 3 in this. So it looks just like this one, except the sign's changed and the sign's on the outside. So here we go, x plus 3, close the parentheses. Yeah, that looks good. All right, so now I'm going to hit graph. Now remember the first one starts in the middle. Now look where the second one goes. Wow, it's like upside down. All right, so it reflects. All right, and it also shifts. So it reflects across the x-axis. How do I know it's the x-axis and not the y? Because look, they're like away from each other. Now, if you look, this one starts down here. So it shifted 3 to the left. Okay, look, remember that's a positive. So remember what's inside is going to make it go left or right. Since that's a positive, like we said over here, it's a positive, it goes to the left. All right. If this was a negative inside, it would go that way. All right, like it did here. See, it was negative and it went that way. So this one's going to do two things. It's going to flip and then shift over. Now we're looking at where it starts at. It starts at 0, 0. So it flips. Think about this thing flipping, and then it shifts this way. So it reflects over the x-axis and shifts 3 units to the left. Perfect. All right, well, it's the domain. It's nice to do this. Now, if you want to, go ahead and delete that, and then just hit graph and just, all I did was delete the parent function. Now I can look at it. There's a little glare there, sorry. Okay, so the domain is X. So right here, remember, X is this one. So I got to know where it starts at. It starts at -3. So I'll include -3. Where does it stop on the x-axis? Well, it keeps going, 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 going. That means this keeps going, going, this keeps going, going, going. So it's infinity, positive infinity. And we'll put an exclude. Now be careful. The range is up and down. It's y. All right. So now look, where is the lowest that it goes? The lowest it goes. All right. The lowest it goes looks like a negative infinity, because this is still going lower, lower, lower. This is down here. So this is going to be a open, and it's going to be negative infinity. Why is it negative? Because these numbers are negative and this line is going down, 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 down. And we can't include it because we don't know where it starts down here. I mean, it could be way down here and we just don't know it. But what's the highest it goes? 0. And notice how we know it stops at 0. Okay. And there's your answers for those. The next ones are kind of fun. I like these. All right. These are really fun to do. And so, so these are always solving by the square root. So here we go. All right, so I'm just going to go ahead and write the problem like you would see it. You see the square root here. To get rid of a square root, we always do the square to both sides. So I'm actually going to take, I hope this pen works. I'm going to take the opposite, which is a square, and I'm going to square both sides. Remember, these cancel out. So I'm going to have x squared minus 16 equals 9, because 3 times 3 is 9. Then I'm going to add 16 to both sides of the equal sign. I get x squared equals 25. All right, now look, the opposite of square root. Okay, and I'm going to write this again so you can see every little step. If I could write, it'd be great. The opposite of square root is square, or square is square root. All right, so now the x, these cancel each other out. So you got x equals. Now, this is your square root. So you could put this in your calculator. Mark and clear this. So you could, and the way to do it is hit second, because quit is in yellow, hit second quit. All right, so I'm going to put the square root of 25 in here. All right, so I'm going to hit second, square root, put 25, and hit enter. And I get 5. Now, be patient, because it also could be -5. All right, it's one of those things that's kind of tricky, because think about it. You could have 5 times 5, which is 25. And you could have -5 times -5 is 25. So look, 5 times 5 equals 25. And you can have a -5 times a -5 equals a positive 25. So the answer is really x is plus and a -5. That means you have two answers. You have a +5, -5 is one of your answers, and +5 is one of your answers. Let's go to the next one. All right, we want to do the same thing. We want to do the square root to both sides. So I'm going to go ahead and write the problem down so you can see it. All right, so I'm going to get rid of that. So I'm going to do the square to both sides. Now notice this, I'm going to do all of this with the square. This is going to be 2x. Remember, these are opposite of each other. This is going to be x minus 4 square. All right. Excuse me. So I'm just going to go ahead and fix this up. Now, I'm going to simplify this. This really means x minus 4 times x minus 4. Okay, I'm multiplying this. So I'm going to put this down here. This is where you do the double distributive method. X times x is x squared. X times a negative 4 is a negative 4x. A negative 4 times that is a negative 4x. A negative times a negative is a positive 16. We always combine the guys in the middle. All right, so this should be x squared, a negative 4x, a negative 4x, a negative 8x, and plus 16. And this equals 2x. Now, like we did when you came over, is I want to put all this together. So this is a positive, so I'm going to subtract 2x. And look where I line it up at, right under the other x. This becomes 0. This is x squared. Minus and a minus gives me a minus 10x. This is plus 16. All right, so now you got to figure out what two numbers can I multiply together that will give me 16. So you got to think two numbers that will give you 16, but when you add them, okay, you get negative 10. All right, so if you said 16 and 1, because 16 times 1 is 16, but if you add them, you get 17. That's not negative 10. If you do 2 and 8, well, 2 and 8 will give you 10. That's what we want. But it's not negative. But look, if you made both of them negative, two negatives multiplied give you a positive 16. And then when you add negative 2 plus a negative 8, that's a negative 10. So right there is my answer. So it's x minus 2 and x minus 8. Now you got to set them equal to each other. All right, because they're set equal to 0. And I ran out of room, but I'm going to try to do it right here. So x, if you look right here, x minus 2 equals 0. I add 2 to both sides. I get x equals 2. Then the other one is x minus 2 equals 0. I add 8 to both sides. I get x equals 8. So there's my two roots. That's where the x, that's where your parabola is touching the x-axis, the x-intercept. So it looks like this. That's what we found, the two little dots, but they're not. Okay, so that's where they are. Let's do this one. All right, so again, you see the square root. So I'm going to do the square root to both sides, or the square to both sides. This will make 14 plus 5x equals x squared. Notice I don't have an x squared here, so I'm just going to move. I can move everything over here, or I can move this over there. It's simpler just to move this over here. And when I do, I want you to pay attention to this. Notice I don't have an x squared, so I write the x squared first, then I write the x, and then I write the number, because we want it in standard form. Standard form looks like this. It's where you have your x squared, you have your x, and you have your plain number, and it equals 0. Now, we really don't want a negative x squared. So you just change it all to its opposite. So what we're doing is we're just really multiplying everything by negative 1. Negative 1 times negative 1 times negative 1 times negative 1. I mean, think about it, negative 1 times 0 is 0. So it's just changing the sign. So it's going to be positive, a negative, a negative. Now we're going to do what we did earlier. What two numbers multiply together give me 14? And it's negative 14. Make sure you don't do the original. It's negative 14. So negative 14, but when we add them, we get negative 5. All right, so 7 and 2 is the most common. And we can make the negative 7 plus 2, that's negative 14. And if I add negative 7 plus 2, that's negative 5. So right there is my number. So it's x minus 7 and x plus 2. And again, we're going to set them both equal to 0. So just to do like we did earlier, and I'll try to do it. I'm trying to give you room. X minus 7 equals 0. So you know x equals 7. And you have x plus 2 equals 0. I'm asking you, basically what we're doing is saying, what number do I put in for x, add 2 to it to get 0. And so x will equal a -2. So it's always the opposite of what you see here. So instead of the answer being a negative, your answer is a +7. Instead of a +2, it's a -2. So there's my two answers. All right, next one, number 7. This was not a square. It's a cube root. All right, this is a little different, but it's basically the same process. All right, so, oh, I forgot the little 3, didn't I? All right, so if you look, that is a cube root. So we're going to multiply both sides by 3. Or not by 3, by the cube root. All right, so these are going to cancel out. It's just like the square. That's a square. We took the square, it canceled out. So because this is a 3, this is a 3, we're going to cancel them out. But we have to do 5 to the 3rd power here. So make sure you're paying attention to this. All right, so here we go. These will cancel out. So I end up with this. 5 times 5 times 5 is 125. Subtract 3 to both sides. 2x equals 122. Divide both sides by 2, x equals 61. There's my answer. Now, how do I know it's right? I could put 61 in here, multiply by 2, add 3, and find the cube root of it. It should be 5. All right. Let's see here. This one. What is the value that makes this? So we're going to do basically the same thing. I'll be honest with you, I kind of like these. That's a 1/2. I'm going to show you how to do that. They just want to know, does all this equal 9? All right, so watch. You see 1/2 here. 1/2 is the same thing as saying the square root, and that's the 2, and x, and then the 1. So that's your base. It goes inside. The top number is your power, and the bottom number is your index. This is a 2, so it's a square root. So this is what it looks like. See, it's just a fancy exponent. 1/2 means that right there. So now I'm going to take the square to both sides. Oh, I got to do something first. I forgot. I didn't even catch it till just now. I got to subtract 7 from both sides first. I got to get rid of this guy first. I can't do the square root. I got to do this first. I'm going to write this back down. There we go. Now I can do the square root. I couldn't do it because it's a +7. I'd have to square root the whole thing and square root that whole thing. Or square. I keep saying square root. All right, so there we go. So we square both sides. Now this becomes, and this becomes 4 because 2 times 2 is 4. Subtract 2 to both sides. 2x equals 2. Divide by 2. X equals 1. So is it true? Well, here's try it out. And I'm just going to do this because if I do this, it equals 9, then I know it equals 9. So we're going to put a 1 where there's a 2 times 1 is 2. 2 plus 2 is 4. So I'm just going to do it like this so you can see it. So it's 4. And remember what I said about the half? The half means it's a square root. The little 2's here, 4's here, 1's here. Plus 7. So what is the square root of 4? Or otherwise, what number times that gives me 4? It's 2. So 2 plus 7 is 9. Does that equal what they gave us earlier? Yes, it does. All of that equaled 9. And so you can see it's perfect. Okay, next page. All right, the next one is kind of nice because it practices what we just talked about. It says convert these into radical form. A radical form is like this. It's either a square root or a cube root. How do you know if it's a square? You won't see anything. But technically, when you don't see something, that's the same thing as putting a 2 there. If it's a cube root, they're going to put a little 3 there. That means put them in groups of 3, which we did in Algebra 1. So I'm going to show you that same method. But let's get this done first. This is the laws of exponent. We did this as well. So Pay attention to this, okay? So this is my base. So you know you're going to have a radical. The y is your base, so you put it inside. The 1 goes on the inside as an exponent. The 2 goes in the little index, this little check mark, okay? So that's the answer. That's it. All right, so let's do this one. Square root. Put the z in the middle. 1 right there because the 1 goes on there. This 3 goes in the index, which is the little 3 right there. All right, let's do this one. Square root. The base is 2x. Oh, they're trying to trick you, aren't they? All right. The 3 is the index, or let's do this right. 2 is your power. Now we got to put this in parentheses because we want to do the power. See, it's in parentheses. We want to put the 2 to both of these. And then we're going to put the index on the outside. That's how you do those. It's kind of nice. All right. Now, these, we're going to have to really pay attention to these. We did these in my class when we did squares. We did simplifying radicals. All right. Now, watch my strategy. If you might remember this, you might not, what we did in class. Okay, so if you look at it, it has an index of 3. That means the index tells me how many groups we're going to make. All right. If it was a 2, then we'd put them in pairs. If it's a group of 3, if it's a 3 cube, we put 3 of a kind together. If it's a 5, we put 5 of a kind together. All right, so the first thing is I have a 64 here. So I'm going to do the old factor tree like we did in my class. 8 times 8 is 64. What two numbers give me 8, 4, and 2? This one's 4 and 2. Make sure you bring everything down because if you forget one, you're going to mess up. 4 is 2 and 2, bring down my other 2. 4 is 2 and 2, bring down my other 2. Now, these are all prime numbers. I can't make them any smaller. We don't care about 2 times 1. We only care about 2, 3, 4, 5, 6, 7, those numbers. All right. Now, I'm going to go ahead and do the x's. The x to the 5th, there are 5 of them. 1, 2, 3, 4, 5. The y's, there's 12 of them. Oh boy. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 of them. All right, so we have done 64. We broke it down into all 2's. The x's, there's 5 of them, so we put 5. There's y, there's 12 of them. The index is a 3. That means we're going to group them in 3. So I'm going to take three of a kind. So here's a 3 of a kind right there. There's another 3 of a kind. Right. Notice I have 2 groups of 3 of a kind. In our class, I talked about when you circle it, it looks like the word outside. So anything I got circled, it looks like the O for outside. So this goes outside and this goes outside. Since these are numbers, we can multiply them. So 2 times 2 is 4. So I'm going to have a 4 go outside of the radical. All right, let's do the x's. X's, it's 3 of a kind again. Look, there's 3 of a kind. This isn't. It's 2. I can't do this. So now notice, this is a circle. So 3 of a kind. What did I circle? I circled a group of x's. So we're going to put a x on the outside. Now, I still have some x's left over. So I got to give myself room because I have y's here. So I'm going to give myself room. That means whatever's not circled, that's how many goes inside. There are 2 of them. So it's going to be x squared because there's 2 of them. Now let's do the y's. Y's, remember, the index tells me 3 of a kind. So 1 group, 2, 3, 4. So I have 4 groups. So that's a group of Y, that's a group of Y, that's a group of Y, and that's a group. So I'm going to put, what groups did I circle? Y. How many groups do I have? I have 4 of them. And that's how we do it. Let's try this one. So that's my answer. Let's try this one. All right, 27, 9 times 3. That's 3 times 3 times 3. Looks like I have 3 x's. I have 13 y's. Boy, they like a lot of y's, don't they? All right, there's 13. So what I've done is just made it all up. Now, the index is a 3 here. Okay. This one doesn't have one, so you know that's a square. That's a 2. This one's a 3. So I'm going to circle in 3. So I'll start with the numbers. All right, look, there's a group of 3. So I'm going to have, since it's only one group, I'm only going to have 1 3. And remember, the circle means it's outside. Look at my x's. I have 1 group of x's, so that'll be outside. All right, we got to be careful of the y's here. 1, 2, 3, 4. All right, so I had 4 y's outside 4 groups, but I still have a y left over, so that goes inside the box. 1 y. There's my answer. Now, I'm going to show you something that's a little bit of a trick you could do. You see these 3's here? These work really good with the letters. I'm talking about the letters only, not the number. So 3 goes into 5 one time. So you have 1x on the outside. See it? And you have, if you think about what's 3 minus 5, it's 2. So you have 2 left over. 3 goes into 12 4 times. You don't have a remainder, so there's nothing inside. Look at this one. 3 goes into 3 one time. So you have 1x on the outside. We're going to look at the y's. 3 goes into 13 4 times, because look, 3 times 4 is 12, and you have 1 left over, and it goes in the box. So you could do it that way. Now this one, you're going to have to be a little careful here. This is a fraction, so I want to show you how to do this. This is also, there's no index here, so we know it's a 2. So we're going to separate it. All right, so let's list my factors of 4. 2 times 2, that was easy. All right, this one's x times x. Now that's just the top part. The bottom part, I have 5 y's. 1, 2, or 8 y's. 2, 3, 4, 5, 6, 7, 8. 10 z's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. Now my index is a 2, remember? So I'm going to circle them in pairs, just pairs. So there's a pair, that's outside. And that's a pair, that's outside. So my top is going to be 2x. All right, my bottom, I'm going to try to do a different color here, see if I can get a different color. This is not that great. Hopefully this works. All right, so we're going to still do groups of 2. There's 1, there's 2, 3, 4. So there's y4 on the bottom. 1, 2, 3, 4, 5. Z5 on the bottom. See, there's no extra, so it's perfect. There's no more radicals. If you circle everything, there's no radicals. If you have something that's not circled, like these guys here, you're going to have a radical still on the outside. So this is my answer. All right. Now we're going to talk about the section 6. This is write a new function after the transformations are applied to the parent function. Okay, so this one is, we did these in my classroom as well, but it's kind of, it's been a while, so you have to kind of know some things. I would highly suggest that you, I'll try to send you an additional video of just doing how everything shifts left and right, up and down, and that kind of thing, because everything you see here is exactly what we did in our classroom. All right, so let's talk about the way it works. Really, you have f of x, which is y, and you have ax plus h square plus k. If you notice, this is the vertex form. All right, now, if you use this one, it works out great. All right, so there's many things you're going to have to watch out for this. All right, so like when it says reflect, that means your answer is going to be a negative. You're going to have a negative number somewhere, or a negative. If it says a scale factor, that means you're going to multiply it by something, like 3, scale factor 3. When it says translates right or left, right or left, you got to know, or up and down, you got to know these things. So do you see what I have here? I have this equation here. This one tells you if it's positive, you shift up. If it's negative, you shift down. This one here's the opposite. If it's positive, you go to the left. If it's negative, you go to the right. All right. If this is a negative, you reflect. So if that's a negative, you reflect. It means it flips. That's really what it does. It just flips. Now, there's numbers involved here. All right. If you put a number in for x, and then that number is greater than 1, it's on the x, so it's horizontal because it's on the x. If it's on the number outside of the parentheses, it's your vertical. Okay. And it just depends. These have different meanings. So this is horizontal if your number's here. It's vertical if the number's here. Okay, so it's something you're going to have to just kind of study. All right, so but they're asking you, write a flex over the x-axis. All right, so that means I need a negative. All right, now this is the weirdest thing is that you're going to have to put your negative on the outside. So we're going to have something like here. So it's always reflects. So if it says x-axis, your negative is going to be on the outside. So we're going to say f of x, and it's asking us to vertically stretch. Vertically is the y. All right, so we're going to have to. This is really going to have to. You're going to have to kind of watch this. All right, so here we go. We're going to put the 3. We got x squared here. Right here. We're going to take this. So we don't have to. Let's see. Does it translates up? So we know this is a 7. Right there's a 7. We know that's a 7. We're not going side to side, so we know we're not going to have anything here. All right, so this is going to look right now. This is what I'm showing you. It looks like this right now because all I've done was get rid of the side to side, and I know it's a +7. Now, and that's just because I translated up 7 units and I don't move left or right. Remember, the H tells me to go left or right. Well, it doesn't tell me to go left or right, so that's a 0. So we're just going to have an X in the middle. This is telling me to go up 7. So because it's up, I know it's +7. Now I got to figure the scale factor of 3. Okay. It says vertically. All right. So this is very important that we kind of pay attention. If the number is outside the parentheses, okay. So if it's outside of it, then it's vertical. All right. If the number's inside, it's horizontal. So I could put this 3. All right. Remember, it has to be a negative because it's a reflection over the x-axis. So we're going to say x squared +7. All right, now, technically, that's my answer. Now, you could write it in this way if you wanted to. You could distribute, and you could actually get your answer that way as well. So both of these are correct depending on how you write them. All right, so the cube root is the same thing. It's not anything different, all right? So the cube root, the parent function of a cube root looks like this. Okay, so like I said, in my class, we talked about the grandfather of all lines. So I'm going to add something, multiply something, or whatever. All right, so the cube root, it is reflected across the y-axis. All right, so that means I know that my negative is going to be on the outside. All right, and now let's see, it says that we're going to, we know it's a cube root, so we're going to put the cube root here. All right, look at here. It stretches vertically by 3, okay? So we're going to put vertically, so we're going to put the 3. All right, it's going to be, put the 3 right here. And then we're going to, let's see, I'm getting my rules mixed up here. Reflect across the y-axis, okay? So this, we need to put that inside. I didn't put it in the right spot, so it goes here. So it's really square root -3x, that's a cube. And then I think it says translate to the right. So if it translates to the right, you got to have a -5. So here is my answer. All right, let's go with the square root one. All right, so remember the square root looks like this. We're going to add, subtract, multiply, divide, whatever. All right, let's look for something here to help us start off. The square root function reflects across the x-axis, shrunk horizontally. That means the number is on the x. That means we'll put it inside here. All right. So here we go. We're going to put it on the outside. Let's see. What is it? 1/3? 1/2. All right. So it's 1/2. All right. We'll put the square root. We'll put an x here with a little square. We don't have to put the square on there, but we can. And it says it translates 3 units down. And because I know it's going up or down, remember here's like this one, it's going to be outside the little radicals. So I'm going to say -3. All right. So we'll say F. Oh, I think it says reflect too. It says reflect. So don't forget the minus here. So my answer is f of x equals a -1/2 square root x. And they'll put the -3 on the outside. All right. Let's go with inverses. All right, so inverses, there's some steps that you might want to do. All right. And so inverses, I'm going to write some steps, and I think I'd like to write them right here if I can. You've got to memorize this when you're doing inverse. All right, so replace f of x with y, or otherwise replace f of x, put a y there. So that, but this is already a y, so we don't have to change it to y because it's already a y. That's step one. Step two, swap your x and your y variables. I mean, you're just going to swap them. Just flip them. Just this x is going to go here, that y is going to go here. Leave everything else the same. Three, we're going to solve for the new y. Now, I guess you can't write. We're going to solve for y. Now, remember, y is in a different spot now, so that's why we're doing it. And then when we get through with everything, we're going to replace y with f of x. We're just going to replace it. If you have an answer that says y equals and it just says the inverse, then don't worry about replacing it. So here we go. We're going to replace these. So here we go. See how this is? So instead of a y, I'm going to put x equals square root. Instead of a y, x, we're going to put a y. All right. I got to get rid of the minus 7 first. So I got to add 7 to both sides. All right, now this looks very familiar to what we did before. We have a square root, so let's do the square to both sides. Remember, these cancel out. Now look, I'm going to subtract 3 because we want to get y by itself now. So watch what I'm doing. I'm just going to put this together. And I'm going to stop here. Now, if your teacher wants you to put f of x here, you can. Both these answers are the same. It's just the way we write the y value. All right, remember you could wrote it this way. I mean, I'm just flipping it. Doesn't this look like the vertex form up here? You can't see it. In the parentheses, x minus something with a square plus a number. Same thing. Okay, the number outside would be a 1. The number on the A is a 1, so it's the same thing. Okay, and that's the answer for that one. Oh, they want you to put, I'm sorry, they want you to put f of 1. Okay, I forgot to put the little hyphen thing there for that. It's not hyphen, it's -1. You got to put -1 as the inverse. Okay, so it's really -1. All right, so let's do this one. Replace your x and y's. I'm going to subtract my 10 to both sides. Now I'm going to square both sides by 2 because that's a square. X minus 10 square. These cancel out, so we got y minus 3. Add 3 to both sides. So now I got 10 minus x minus 10 square plus 3 equals y. And remember, and I'm just going to switch these around, say y equals x minus 10 square plus 3. Put f of x, and we'll put -1 here because that's the inverse symbol. And then we'll say x minus 10 square plus 3. And technically, that's your answer. Again, that's about, if you need to do it lower, but it just says algebraic. We've done what we're supposed to do. All right, let's have that page. We have one more. All right, this one, you're going to graph. And you're going to plot the table. This one, use your calculator. All right, so I'm going to clear my calculator. And then we're going to put this in there. And this one's used for the calculator. This one is just It's very similar to what we did just a few minutes ago, but it's a very little interesting. So we're almost done. It won't take that much longer. So putting this in the calculator is going to be the fun part. All right, so here we go. I'm going to turn on the calculator. I got to clear my calculator. Do I have anything in there? Nope. Okay, so we're going to start with y equals. So I hit the y equals button because f of x, same thing as y. I'm going to put this in the calculator. Got to be careful. Make sure you put it in just like this one. All right, this one's a little fun. We're going to have a couple of parentheses here, so we need to make sure we do this right. So it'd be 2. All right, I'm going to go ahead and say open parentheses. And the reason why, in fact, I could do, I'll tell you what, it'd probably be better if I do this. I'm going to put a parentheses around this. All right, and the reason why is because when I put it in my calculator, I'm going to need to do it. If you use Desmos, you can type it in. You'd have to type it in that way anyway. So I'm going to go ahead and do it this way. So it'll be 2. Remember, the square root is right here. And then I'm hitting x plus 3. The x is right here. Plus 3. And then I got to close that parentheses because I'm including, now be careful. I have 2 open parentheses. See this one and this one? This closes the parentheses for what's under the radical. Then I got to do another one to close the whole thing, the whole top. Now I got to say minus 7. Okay, let me review. Remember, this already has a parentheses inside. So when you open it up, see, open it, there was a parentheses here. So I got to hit the close parentheses because I want that to be inside the radical. So there's a parentheses just for this guy. So if I was to do this, I'll do it in a different color so you can see it. On the calculator, it looks like this. See, that's the calculator part, and you have to close it. And then you got, I put this in here so we can do this and then subtract by 7. Okay. Now, if I graph it, that's what it'll look like. But let's look at the table because we're making a table. So let's go to second table. If I can hit second table, I keep hitting y equals. All right. So let's look at a couple of things. All right. So you know that could be a, if I put a negative in there, that could change everything. So look, if I put a negative 3 in here, let's look here. Excuse me. Oh my gosh, sorry. Okay. So anyway, negative 3 is a whole number. All right. So we are going to look at this. Let's see if I can go any higher. See, look, negative 4 is an error. Negative 3 is negative 7. All right. So I'm going to start with negative 3. So I'm going to put negative 3 right here. All right. Look, negative 3 is negative 7. All right. Look, I only do the whole numbers that make sense. So like, see, this is negative 2. Oh, you can't see, sorry. This is negative 2 and negative 5. Don't do negative 1 because it's a decimal. Let's just do whole numbers. Negative 2 and negative 5. Okay, what's my next whole number? It's not negative 1. It's not 0. Oh, 1 and negative 3. And then 1, negative 3. That's 2. We need one more spot. You can see. So 2. No, so I'm going to scroll down. Oh, 6 and negative 1. Okay, so there it is. All right. And they want us to graph it, and we'll go back and graph it after we get through. All right. So now they want us to do the inverse. That's what that means. It means replace the y's with the x's. All right. So I'm going to do that math right here. So instead of f of x, I'm going to use y. All right. Now I'm going to replace them. Remember, swap the x and y. So this will be x equals 2, y plus 3, minus 7. All right, now I'm going to solve. Now remember, you have other things being done to the radical. You can't just go square root because it's being subtracted and it's being multiplied. So we got to get rid of the add and subtract first. It's going to add 7 to both sides of that equal sign. So now it's x plus 7 equals 2 times the square root of y plus 3. I still can't do the square root to do the square root of both sides because that's being multiplied by 2. So the opposite is divide both sides by 2. So now I have x plus 7, and that whole thing is being divided by 2. These twos will cancel out. So now I have the square root of y plus 3. Now I can get rid of my square root, and I can square both sides. So I'm going to square this, and I'm going to square this. So this becomes x plus 7 over 2 in parentheses, the whole thing, and the whole thing's being squared. These will cancel each other out, so you just have y plus 3. Now I got to get the y by itself, so it's being added by 3, so I'm going to subtract 3. Now I'm subtracting -3 to all of this, all this. I'm not going to just do it, so I'm just going to write it this way. These will cancel out, so we got y equals, this right here will be open parentheses, x plus 7, divide by 2, close the parentheses, and square it, and now subtract by 3. See, all this is being subtracted by 3. All this is being subtracted by 3. So there it is. And remember, we're going to change this to f at -1. So there we go. Now guess what I'm going to do? Now I'm going to go to the y equals, and I'll put all this in my calculator. Now this is going to be fun to put in, because you got to be very careful here. I got to put a parentheses around this guy, and then divide it, and then put a parentheses around the whole thing, square it, and then subtract by 2. And I have an old calculator, so my old calculator is a little different, and I have to do a little bit more. So I'm going to go to y equals. I'm going to hit clear, and I got to be very careful how I'm going to do this. All right, so I got to have an open parentheses, another open parentheses, x plus 7, close the parentheses, then divide by 2, and then I'm closing that parentheses, that's the big one. Then I got to hit the square button. Remember the square, you can either hit that or hit that, it doesn't matter. It doesn't matter. I always have a habit of hitting, oh, you can't see. I have a habit of hitting that and hitting 2, or you can hit that for 2. All right, now, after I square it, okay, so I square it, I didn't put enough. I got to say -3. If I put -3 here, it may think that I'm trying to take the exponent 2 and subtract 3 to it. So I've got to go back. And if you ever have to do this, you can always go to the bin. I got to put another parentheses in here. There's a button here. I keep thinking you can see INS. That means insert. It's in yellow. So I can hit second and the delete. And if you notice, now it's blinking. So now I can hit the here. And now I got 3 of them. See? Now I'm going to scroll over to the 2. And I'm going to insert. I'm going to put in a parentheses again. So now I have 3 here, 1, 2, 3, 1, 2, 3, and now I can say subtract 3. You might have to watch this video a couple of times on this part just so you can make sure. But again, you may have this, you have an 84 probably, and you have a newer calculator, so you have a little bit different functions, but this is how it does. All right, now I have it in my calculator. Now I'm going to go to the table. Let's find out what happens. Okay. I didn't enter something in right because I know my answers are not that way. Let me go back. Open parentheses, x plus 7. Oh, I put divide. I didn't put this. No, that's right. Divide by 2. So it takes this, divides it by 2. And then take the square and subtract 3 from it. Looks right. All right, so let's hit graph. Let's hit graph, see what happens. Okay, that is correct. Right, that is correct. So let's go back to my table. Oh, I remember what happened here. Okay, so let's go. And I like to look at these numbers. See where it says x is -1, 2. So I'm trying to start off. So I'm going to find where my values are even. Okay, so all right, so watch. Now, if really what we did is we swapped them. Remember, we swapped our x's and y's. So really, my x over here is going to be my y values here. And what my y values here, they should be my same x values. So let's try it out and see. All right, so we're going to go to -1. So let's go up. Look, -1 and 6. It's the opposite. So we're going to put -1. Let's do it in different colors so we see it. So my x value here is -1 and my y value is 6. See how they're opposite? All right, so now I'm going to go to -3. Look, -3 and 1. See, look, -6, 1, and 6 is the opposite of what the other ones. This is the inverse. Remember, it's like flipping it. This is -3 and 1. But the next one's -5 and -2. -5 and -2. And the next one should be -7 and -3. There it is. So it's perfect. So we know we got it right. Now, graphing this. All right, so let's say you have to graph this. All right, so to graph this, there's a couple of things to do. You can put both of them in if you want to, which I would. Let's do this one since we already have it. We're going to hit graph. Kind of notice you could almost really just graph it from here. And it's probably better to graph it from here. And the reason why, so you're trying not to use your calculator, but you should know what it kind of looks like. So this is the inverse one. So we're going to do this one first. So I'm going to take this one. And since those are in purple numbers, I'm going to just do it in purple. All right, so I'm going to go, we're -7. That's my x value, which is right here. And I'm going to go down 3. 1, 2, 3. -5 and 2. 1, 2. -3 and 1. Well, that's a positive one, so be careful. -1 and +6. Okay. And look, you see what it looks like. It looks like it goes all the way. It also curves back up to 10. So something like that. All right, now we can go do the other one. And we'll do it just in dark. -3, -7. Okay. -2, -5. 1 and -3. And 6 and -1. So this one looks like it starts something like this. All right, and you can put both of them in to see. So like I can go back down here and I can put this other one in here just to make it look, to see if it looks just like, I'm looking, I can't believe I'm looking for the Y equals button. All right, so I'm gonna put this in just like you see it. So I'm gonna put the open parentheses, 2, and then hit the second square root. It's already got my thing in there, so I'm gonna say x plus 3. You can't see, I know I keep forgetting to do x plus 3. Close it, then close it again, and say -7. And now we hit graph, and these two should look very similar. If you can see them. Very similar. All right. All right. I'm gonna pause it for a second, take a little break, and then finish the last ones. Okay. The next one is dealing with determining f of x and g of x are inverse of each other. Okay, and so there's a couple things you got to make sure you know how to do or what you're doing here. All right, so I'm going to say what we're going to do is we're going to take this g of x and we're going to put it inside of this f of x. And then we're going to reverse it. Then we're going to take this and put it inside here. So let me show you how I would write this. I would write this as so I'm going to take g of x, this value here, and plug it in for the x value here. And then I'm going to take this here and plug it in for this x value here. And if the two answers become the same, then it is good. All right, so let's try this. All right, so my g of x is going to go inside here. So this is this cube root, and I'll put this in here. And then I'm subtract 1. So remember, look, this is a cube root, that's a cube, and so they cancel each other out. So this would be x plus 1, and we have a -1. So x minus 1, so that equals x. So the first one's x. Now I'm going to take this and plug it into here. So we're going to take the g, and we're going to put it in the f inside the g. All right, so this f goes inside. Well, I just put the g in there. Now I put this in here. So we're going to say open, and this is the cube root of x minus 1. That's the x part, and then plus 1, and then a cube. Just make sure I did this right. So all this goes here. I didn't really need that. All right, so let's do this. All right, so it's cube root of x, -1 plus 1 is 0. And is it? So remember, these two cancel each other out. So my answer is just x. So look, this one and this one. So this one is a yes because they both match. All right, so let's do the same thing here. So we're going to say f g of x. So we're going to put the g inside this. So all this is going to go for x. So instead of x, I'm going to put all this. And I put the parentheses because that represents the x. See, all this represents the x. Now, I have to distribute first, just like you normally do. So I'm multiplying this to this, and then multiply that. And so 3 times 4 is 12 over 12x, which is 1. Minus 3 times that is 15 over 4. That's x minus 15 over 4 plus, I put 15 here, but it's supposed to be 5. All right, I got to get a common denominator because I got to put these two together. So if I want to make this a 4, I got to multiply the top and bottom by 4. So I got to, like 1, multiply by 4, multiply by 4. So that way it looks like this, 20 over 4. Because remember, when you add and subtract fractions, you have to have a common denominator. So when I do this, I get x equals 5/4. All right, let's do the other one over here because I'm going to run a room. So we'll say g and put f of x here. So I'm just going to put it right here. All right, so f of x goes inside this guy. So it's 4/3. So all this goes in right there. And then I have the -5. So again, I do the distributors. 4 times 3 is 12. 3 times 4 is 12. So these kind of cancel each other out. But then I got to multiply 4 to the 5. So it's x. 4 times 5 is 20 over 3. So I got to make common denominator. So this has got to be a 3. So I multiply 3 here, 3 here. I get 20 over 3 minus 15 over 3. And so x is 20 minus 15 is 5 over 3. I think I forgot the x. Oh, this is a minus, not an equal. Minus. So there's that one, and there's that one. And you can see that they are not the same. So this is a no. All right, that's how you do this. All right, now the next one. The next one is a power regression. All right, you do this on your calculator. We did these very similar to my class. We did linear regression, quadratic regression, and exponential. The formula for a power regression is y equals a times b equal x. X of b. Let me rewrite this because that's terrible. Y equals a times x with a b. Now, the exponential is reverse. It's a times b with the exponent. All right. So how do we do this? All right. So the first thing we need to do, all right, is we need to input the data. So we're going to take this. Now watch how this, I'm going to clear this calculator just so we don't have anything. So I'm going to hit second plus 7, 1, 2. Now remember, your calculator could be a little different than mine when you're doing this. All right. So the first thing we're going to do is we're going to type in the data. All right. So we got to go to, we'll hit stat, that button right there. You're going to go to edit. And so you hit 1. You see where it says L1, L2? We're going to put this in for X, this in for Y. So I'm just going to type in 1 and enter, 2, enter, 3, enter, 7, enter, 8, enter, 12, enter. Do this one. 134, enter. 167, enter. 217, enter. 328, enter. 338, enter. 404, enter. So I got everything in. All right, so the next thing you do is hit stat again, same button. This time you go over to calc. All right, these are all the regressions. So we did linear regression, we did quadratic regression, we did exponential. So you scroll down. Like I said, my calculus is a little different than yours. All right, there's the exponential. And look, there's the power one. It's the letter A. So we hit enter. All right, now I've got to tell it, because my calculator is different. I've got to tell it that I want L1 and L2. All right, like I said, every calculator is different. So your calculator, being newer, might have a different function on it, but my L1 is right here with the 1. So it's yellow, so I'm going to hit second and 1. So it should say that. And then I got to hit the comma button, okay, because I got to separate it. So the comma button's here. And then I got to go L2, which is right here. Now, like I said, you may not have to do this exactly like this, but it's very similar the same way. I hit enter. It's calculating. All right, so there it is. There's mine, and there's the same equation that we have here, the exact same equation. So my A, all right, my A is 129.382. My B is 0.462127. So they want to know, write the model, the equation. So it's Y equals, my A is 129. And that says round to the nearest tenth. That's only the first decimal places. So I go next door. Is this 5 or greater? Yes. So I'm going to say 0.4. And then we're going to put X, because that's what's next. And then the B value, it says again, round to the nearest tenth. That's right here. So I go over, that's a 5 or more. So we're going to put 0.5. So right there is my answer. Now, the newer calculators, they like to put, they go ahead and they show you the whole thing. They even put the whole answer in there, but that's how basically it works. That's it. Good luck to you.